So, good morning everyone. It's very early in the morning. Usually I wake up at 12 plus only. Okay, my name is teacher Shannon. I graduated from NTU with a chemistry degree. I taught for about 7 years. Okay, and yeah, I think one interesting fact about me was when I was in secondary school, I was a competitive gamer. So last time in secondary school, if you Google my name, you can find me. Last time, the game closed down already. Okay. Yes, and this is not really to flex because if you go and search TikTok, Reddit, you will see a lot of academic comeback. But it's not just me. A lot of students actually can do it. This is more like to motivate you and to show you that it's definitely possible. So I always tell my students, it's whether you want, not whether you can. Yeah, F9 to A1 definitely possible. It's whether you want, not whether you can. Okay, this includes all the Sept and N levels that are joining us. So just quick introduction about OVERMUGGED. Yes, we have quite a lot of students. Then we recently opened at Jurong East and Tampines. Okay, so we have about 7 branches now. And yes, a lot of the teachers, they are ex-MOE from Learning Lab and stuff. So good track record as well. Okay, so we have quite a lot of resources, especially for sciences. We do have notes for practicals as well, but usually this is only given in secondary 4. Okay, similar to your school, schools will only usually focus on practical in secondary 4. So we do have practical sessions as well. And yep, many other notes and stuff. Okay, so let's go into today's content. Okay, let me just close this. Oops. Today one is here. I'll start off with Chem for the first 1.5 hours, then we'll go to physics. Yeah. The revision kit that most of you have will include all the topics, but today I will just focus on the main 3. I'm not sure how many of you are aware of that. On Instagram, we actually released the main 3 topics. So today we'll mainly cover chemical bonding, chemical formula equation, and acid bases for combined chemistry. So let's start with chemical bonding. This will set the whole context. Why do things want to form chemical bonds? Why do atoms gain or lose electrons? Okay, it's because they want to achieve stable electronic configuration. Simply put, they just want to achieve full outer shell. And how do they do it? They gain or lose electrons. Atoms at first, they are neutral. Why? Because same number of proton and electron. At first, they are neutral. And they get a full shell by gaining or losing electrons. So maybe a simple example is lithium. No. Let's use sodium instead. Okay, these are optional to draw. This more to help you visualize. Sodium proton number or atomic number is 2.8.1. So this is sodium atom, 2.8.1. Okay, then proton, 11, electron, 11, neutron, 12. Okay, how do I get all these numbers? If you look inside your periodic table, sodium will look something like that. The mass number is 23, proton number 11. You want to get number of neutrons? Just take mass minus proton. So this is your sodium atom. Okay, let me go and close. So how does sodium atom get a full shell? What's the quickest way to do it? It will actually kick out this one electron. Okay, then now it will become... Okay, if you prefer to do X, you can do that. And now you have a bracket and plus charge. It lost 1 electron. It lost 1 negative charge. Okay, so number of protons, 11. Electrons, 10. Lose 1 electron. Your number of neutrons is still 12. So the only thing that changes when atoms become ions is they lose electron. Nothing else changes. In this case, lose 1. You lose 1 negative charge, so now you have plus charge. Another way to look at it is you have 11 positive charge, 10 negative charge overall, plus 1 charge. Okay, so hopefully this is clear. I will set the context of why atoms gain and lose electrons. Usually your non-metals will gain, then your metals will lose. Okay, non-metals will gain, metals will lose, usually. So for example, your non-metals on the right side of the periodic table, for example, oxygen. Oxygen is 2.6. Already got 6 in the outer shell. What's the quickest way to get full shell? It will gain 2. So after losing electrons, now the number of protons will be greater than the number of electrons. So they form positively charged ions known as cations. Okay, then some students came out with this. Like some students like cat. So cat is a positive thing. I don't know. Some students came out with that. Then for your atoms that gain electrons, your number of protons is lesser than number of electrons. You gain electrons. So now you got more electrons. Overall, you have negative charge, and that's what we call anions. For combined science syllabus, there's only 2 different kinds of bonding. There's ionic bonding and covalent bonding. The first one, ionic bonding, is usually between your metals plus non-metal. Okay, y'all can write this or this, as long as you understand what you are writing, metal, non-metal. Because this will determine like your thought process. You need to first identify what they are testing you. So it's very important that you know they are being tested on ionic bonding or covalent bonding. Otherwise, later your answer behind all wrong. Okay, so ionic bonding involves the transfer of electrons. Hopefully you can see that sodium atom totally give or totally transfer electron to chlorine. So what does sodium atom do? It will lose 1 electron to form Na plus ion. On the other hand, your chlorine atom gain 1 electron to form Cl minus ion. And because you have 2 things of opposite charge, they attract each other. Okay, in physics Sect 4, you all will learn as well, opposite charges can attract each other. And that's actually your ionic bonding, which we describe as electrostatic forces of attraction. So yes, I know this looks pretty simple, but they can test. You write this, you get 1 mark. They'll ask you to describe the formation of sodium ion from sodium atom. How do you make sodium ion? Starting from sodium atom. You just write this, you get 1 mark. Okay. You are expected to draw dot and cross as well. Dot and cross got 2 kinds. That's why I say it's very important you identify what they are testing. Is it ionic bonding or covalent bonding? So you can draw the correct one. Whenever you draw your ionic bonding dot and cross, make sure you have your brackets and charges. Okay, these are just 3 checkpoints. Remember, the whole point of chemical bonding is they want to get full shell. So after you draw dot and cross, you check everything got full shell or not. Make sure all electrons are paired up as well. No electrons should be alone. Okay, if you can satisfy these 2 criteria, usually you are correct already. This one applies for a covalent bonding side also. After covalent bonding sharing electrons, these 2 rules should be fulfilled. No electrons left alone. Everything should have full shell after sharing. For covalent also. Must you draw 2 like this? Not really. This one you follow your teacher. If they want, then you give them, no choice. But O level, you can just write like a 2 in front instead of drawing 2 times. Okay? Is legend necessary or not? O levels, no. But your teacher wants same thing, just give them. Yeah. Like legend is this thing over here. If your teacher wants, just give them lah. They are the one marking your paper ma. Okay. Then covalent bonding is between your non-metals. If you see non-metals only, then covalent bonding lah. Apart from gaining or losing electrons, atoms can also share electrons to obtain full outer shell. This usually occurs between your non-metal atoms. Let's say we look at chlorine. Chlorine is an element because there's only 1 type of atom, right? It's just like Cl, Cl, 1 type of atom only. Okay, then maybe I draw like this instead. Some of you may have seen like this kind of diagram before. So this is just a simpler version of what the actual substance is lah. Okay, each chlorine atom has an electronic configuration of 287 because if you look inside your periodic table, it will be 35.5 and 17. Okay, inside your periodic table, not supposed to memorize. Hence, your chlorine atom each require one more electron for full shell. The general idea for covalent bonding is need how many? Share how many? So if you need one, it will share one. Okay, if you need two, it will share two. Later I'll use the example below to illustrate this as well. Okay, need how many? Share how many? Okay, so this actually explains why your chlorine gas exists as a diatomic molecule, group of two atoms chemically bonded together. Di means two. Okay, di means two. They don't exist alone like that because they want to get full shell. So they find a partner. Then they pair up. So this is for your elements. Covalent bonding can happen in compounds as well. Compounds is where you have two or more types of atoms. So let's say if I were to use a simple diagram to show carbon dioxide, it will look something like this. You hopefully can see two different types of atoms. So this is what we call compound. Two different types of atoms chemically bonded together, right? They are stick together. Carbon atom need 4 more in the outer shell. Hopefully you can see that it will share 4. All 4 circles are in the overlap area. So that's what I meant by the previous sentence just now. Generally, it needs how many, it will share how many. On the other hand, your oxygen need 2 more, right? Got 6 already, need 2 more. Each oxygen will share 2. Okay. Usually your covalent dot and cross, if you realize, is also symmetrical. That's another hint for you all. So as you can see, everything paired up. After sharing, everything full shell. So this one kind of belongs to both C and O. When you count, oxygen got 8, not like 4 or 6. After sharing, considered 8. Just want to clarify that. Okay. Last page for chemical bonding, then we look at the question. So there is generally 2 different types of substance, your ionic compounds and covalent substance. Why do I use the word substance over here? Because it can be element or compounds. Okay, but ionic will always be compound because got 2 things, metal, non-metal. So ionic compounds look like this. This is what we call giant ionic lattice structure. Lattice simply means 3D. In case you're wondering what's that, lattice just means 3D. How do you explain why ionic compounds have high melting point? So the sodium chloride that you eat, NaCl, the melting point is about 801. Okay, sodium chloride or ionic compounds have very high melting point. The exam questions will ask you in terms of structure and bonding. Explain. So tell me the structure first. Giant ionic lattice structure. And usually if you can write that, it's 1 mark already. Quite short, right? Because it's giant, you need a lot of energy. Large amount of energy. Overcome strong electrostatic forces of attraction. So if you find this chunk of information very difficult, you can use point form to help you guide your thoughts. Point form means something like that. These 5 words, strong electrostatic forces of attraction. For these 5 over here, these 5 words. See if it helps. To help you all recall the correct keywords. Then you just conclude, therefore high melting point and boiling point. This usually explains why ionic compounds are solids at room temperature and pressure. High melting point and boiling point. Therefore, they are usually solids. Then on the other hand, it's just the opposite. Simple molecular structure, small amount of energy, because overcome weak intermolecular forces of attraction. So WIFOA. Therefore, low melting point and boiling point. If you notice, the main keyword difference is over here, the electrostatic and intermolecular. How to remember which is which? Right? Link back to the structure, molecular structure, right? So intermolecular. You all heard about interclass, interschool. Inter means between. So when I'm talking about intermolecular forces, I'm referring to all this over here. I am trying to break all this. I'm not breaking the covalent bond between the iodine atoms. I'm breaking the weak intermolecular forces between the iodine molecules. I'm not breaking this covalent bond. I'm overcoming all these weak intermolecular forces. In your syllabus, at no point you should be writing breaking covalent bonds. Combined science don't have, only pure. Okay? Combined science is just these two only. Then, to follow up on that, so as I mentioned, when simple covalent substances are undergoing a state change, melting, boiling, heat energy is used to overcome the weak intermolecular forces. You are not breaking the covalent bonds. So let's say when you heat iodine, right, what's going to happen is that all these molecules, they are just going to move further apart from each other after you heat. It's not like after you heat, then suddenly everything breaks up to atoms again. No. Okay? Covalent bonds are not broken. Yeah, common misconception. Covalent bonds are strong, they are not broken. Yeah, mention over here. Okay, then this one will be the most commonly tested. It's a very distinctive factor. Only ionic compounds can conduct in the molten, which is liquid, and aqueous state. Aqueous means dissolved in water. Ionic compounds cannot conduct in the solid state, only molten and aqueous state. On the other hand, your simple molecular structure, those substances cannot conduct in any state except acids. Okay, now we are done for chemical bonding. We can look at some questions. Okay, take a break from my yapping for a while. That's it. This should be page 36. Okay, if you can identify what they are testing, actually a lot of questions in chemistry you can solve in a few seconds. So for example, if you can recognize that this ionic, just like I mentioned, right? Ionic compounds can conduct in molten or aqueous state. Ionic compound consists of what? Metal, non-metal. And there you have it, your answer. Okay, ionic compounds, metal plus non-metal. In your syllabus, there's only one thing that can conduct in solid state, which is your metals. Metals can conduct electricity in the solid state. So sodium. If you use this, you will get an answer immediately also. This one, your simple molecular structure cannot conduct in any state. Okay, answer will be B for this. Okay, for those attending online, if you've got questions, you just put in the chat. Then question 7. Which pair of elements could be Y and Z? I'm not sure how many of you attempted this, but the so-called correct procedure is actually to determine what group does Y belong to first. Your Y belongs to group 16 because there's 6 outer shell electrons. The ones place of the group number will actually tell you the number of valence electrons. For Z, I see 7 crosses, so 7 valence electron, group 17. And then you just go and find your answer. Group 16, group 16, group 17. So use the number of outer shell electrons to determine the group, and then you go and find your answer. Okay, those that are done can flip to page 40, question 12. Sodium can react with sulfur to form sodium sulfide. Draw a dot and cross, showing the arrangement of the valence electron shell. Okay, so then I mentioned identify ionic or covalent first. Because if your first step is wrong, everything behind is wrong. I see metal, non-metal. So ionic lah. Ionic is the bracket with the charged one. This step optional. If you think it's helpful, then you can do this. But if you can get the answer straight away, then yeah, sure, please go ahead. Split up the electrons, 2.8.1. Sulfur 2.8.6. This is your electronic configuration. Remember, the whole point is to get full shell. What will sodium do? Lose 1, gain 2. To make full outer shell. So you just draw. Plus. Then your sulfur, okay, which makes the sulfide. Not sure how many of you recall as well. When filling up your dot and cross, most of your teacher will say fill up one by one before you pair them up. So I show the mistake first. I mean, because this is faster, so usually students will like to do this. But just take note, some teachers don't accept this in your school. They will mark wrong. Okay, your teachers will probably tell you fill up singly first, so you want to do clockwise, north, south, east, west, anti-clockwise, so you should be circle. Okay, 6 already, then gain 2 more from sodium, so got 2 crosses, then 2 minus. So the red color one is the more correct one. So this is the reason why some school teachers will mark this wrong. Yeah. Okay. Got the worksheet. Next. Sulfur can also react with carbon, which is another non-metal. Wait, something missing. This is plus, this is 2 minus. Okay, I need to balance the charges. Sulfur gain 2 electrons, right? So I need to have 2 sodium, because each sodium only lose 1. Basically, you balance the charge. I need 2 of this plus plus to balance the 2 minus. Okay. So, yeah, please try to understand dot and cross diagram. I can guarantee plus shock it will come out for end of year. 1 or 2, I don't know. They can test both, they can just test one. Sulfur can react with carbon to form carbon disulfide. Usually you see this kind of naming is covalent. For example, carbon dioxide. Okay, this kind of naming is covalent, which we'll look at later under chemical formulas. Okay, predict. So this is non-metal only, so covalent. What do you know about covalent substances? Cannot conduct. Right? Then why? As it does not have mobile ions or mobile electrons. Key concept for electrical conductivity actually very straightforward. You want to conduct electricity, you must have either mobile ions or mobile electrons. Just one can already. You don't have either, cannot conduct. So your mobile ions is usually for your ionic compounds. Why ionic compounds can conduct in molten and aqueous state? Because of mobile ions. Mobile electrons is your metals. Metals got free moving electrons. This one you all under physics also. That's why good conductor of heat. Okay, then yes, you all see this phrasing. Why is it a gas? So tell me about the structure first. Okay. Carbon disulfide has a simple molecular structure. Usually schools will give 1 mark for this. So not all, it's not like every time you need to write very long to get the marks. Sometimes you need to write very short to get the marks. Okay, the second point a bit harder to get. Because it's simple, small amount of energy is needed to overcome the weak intermolecular FOA between the molecules. Then you just conclude, hence it has a low melting point and boiling point. Low melting point, boiling point, therefore exists as gas. Just make sure you all spell out during exam. Important is to understand today, because we got quite a lot of things to cover. So this can go up to 3 marks. If it's 3 marks, then it'll be 1, 1, 1. If let's say if it's 2 marks, then usually this will be 1 mark, then this will be 1 mark. Yeah, I know, quite unproportionate. Something to take note when explaining all these kind of things as well is there shouldn't be any contradiction. So just now if you all see, okay, can just use this. Simple, small, weak, low. The keywords support each other. You shouldn't be contradicting yourself. I know sometimes you all like to smoke, right? But please don't contradict yourself. That one, Cambridge every year say students write very long, contradict themselves, then they minus mark. Every year Cambridge will say one. Cause try to smoke. Okay. Right, let's go to chemical formulas. The chemical formula is 20. This is 16. Okay. Okay, don't worry if you cannot copy finish. Later I can show you during the break. Okay, there will be break. Or you can get the answer key from me at the end of the lesson. Important to understand because quite rush. Okay. Right, chemical formula. So just now we discussed a few different types of substances. The first one is your ionic compounds. Ionic compounds consist of ions, right, charged particles, metal and non-metal usually. You are not supposed to memorize chemical formulas. Okay, if you are trying to do that, then yes, that's why you find chemistry difficult. Because no one is going to memorize 3 plus 4. Instead, you understand how the plus works. Same thing over here. You are not supposed to memorize chemical formula. If you are doing that, wrong way to study chem already. That's why you find difficult. Okay, instead, you should be understanding how the plus work. In this case, balancing the charges of the ions to get any chemical formula that you need. Okay, I'm not saying that you totally don't memorize anything over here. Still got a bit. Okay, but I'm cutting down by a lot for you all. Usually what happens in school is your teacher will give you one whole page, ask you to go and memorize, but actually you just need this 7. Here. Okay, got 4 here. Later I'll give you all the last 3. So let's see how the balancing of the charges work first. Plus, minus. Happy, right? So 1-to-1 ratio. Okay, plus and minus. 2 plus, 2 minus. So 1-to-1 ratio. Do take note that these 2 minus belong to the whole thing. You need to see as like one set. Okay, like one whole set. K plus SO4 2 minus plus 2 minus. Not enough, right? I need one more. So this is why we write K2. Same thing over here. OH minus you need to see as a set. 2 plus minus, not enough. I need 2 sets. In this case, I will need bracket. Because if you just write this, then the 2 applies to the H only. You don't get a full set. Which is wrong. Okay, don't write there. Later we still need a space. You can write at the top. Same thing over here. Al3 plus, NO3 minus. 3 plus minus. Minus. I need 3 sets. Okay, so when do we need brackets is for your polyatomic ions. Maybe I just write here. It's needed if you need multiple polyatomic ions. Poly simply means many. Polyatomic means many atoms. These are examples of polyatomic ions. Can you see that these ions are made up of 2 or more atoms? So for example, this is made up of 1 C and 3 oxygen atoms to form this ion. This is what we call polyatomic. Okay. I'll give you the others. This one is just 3 more examples. Ammonium is NH4 plus. This is not to be confused with NH3, ammonia gas. Ammonium is an ion. Sulfate, silver, chloride, zinc, hydroxide. Okay, so the other 3 that you need to memorize is here. Total 7 only. With these 7, you can build almost any chemical formula you want. For ionic compounds. Then you want to get a chemical formula, just balance the charges. You all can try. You all can write over here. Okay, some of you probably done. I need 2 sets of this. So I just AgCl. For those that learn QA already, the last two should be familiar to you. The flowchart question. Okay. So this is for ionic compounds. When you are dealing with ionic compounds, then you use this ions method to help you get the chemical formula. There will be other substances. For covalent substances, usually a bit easier. Okay, wait, before that, why I say you only need to memorize these 7 is because most of your school probably will tell you to label like, most of your school will probably ask you to do this. Okay, that's how you get the charges for these ions. So Na is always plus, Li plus, Na plus, K plus. Oops, sorry. Then for example, magnesium will be 2 plus. That's why the rest don't need memorize. Periodic table can help you, but the 7, your your zinc, silver, they are in the middle. That's why you need to memorize. Okay, they won't really test the others they will give you hint. Anything else? Okay, then you also need to recognize this part of your periodic table. These are your diatomic elements. So means these substances always exist as a pair of atoms. O2, okay, you all don't have this okay, periodic table. Just roughly know. O2, Cl2, Br2, all this chemical formula is fixed one. Most students will know oxygen is O2. Hydrogen as well. These are our diatomic elements. Okay, you all can write over here. So for example, all the gen, oxygen, nitrogen, hydrogen, anything gen is diatomic. Group 17. For those that learn periodic table already, group 17 they are called halogen, right? Gen, so diatomic. Anything gen is diatomic. Always exists as a pair. Then there are some other substances. Water, ammonia, right, you are expected to know. Last reminder, this is not to be confused with ammonium ion, NH4+. One is ammonium, the other one is ammonia. Okay, don't confuse. Just now I also mentioned that usually you will see this kind of naming system for your covalent substances. 1, 2, 3, 4. Okay, hopefully you can see 1, 2, 3, 4. So if you struggle with chemical equations, make sure you work on this first. You cannot write formula, you cannot write equation. Okay, and equations, the mark a bit hard to get because one wrong, everything wrong. So make sure you get this first. Because sometimes you will see marks like, write the chemical formula of sodium oxide, for example. Then you just write this, you get 1 mark. Right, get all these easy marks first. Okay, then once you are familiar with this, you are confident already, then you look at chemical equations. Okay, a balanced chemical equation, as the name suggests, balanced. There should be the same number of atoms on the left side and on the right side. This looks very scary and foreign to you, but if you really like drawing, you can always draw out to visualize. For a start, okay? Exam no time. To help you make sense. 1 unit of CH4 react with 2 units of oxygen. to give me 1 unit of carbon dioxide and 2 units of water. Water is also very special. You have this like Mickey Mouse shape. I don't think there are other substances that have this shape, only water. Right, 2 units of water. So for those that learn moles already, right, moles is essentially just units. Quantity ma, just think of it that way lah. Hopefully you can see that the number of oxygen on both sides is the same. There's 4 oxygen on the left, 4 oxygen on the right. So visually your chemical equation looks something like that. Then 3 common examples. Not say common lah. This is just to guide you. First one, what would you all write? You can use pencil first. I think half will get wrong. I know it looks very harmless, but yes, I purposely put this here. Yeah, so if you write this 2, you are wrong. Okay. Why? Hydrogen, oxygen, diatomic, water. So why a lot of students cannot do chemical equation? Because their sequence is wrong. Balancing is always the last step. Formula correct first. Balance is the last step. Then you put 2 here and 2 here. That's how you're supposed to do. Because if the equation is 2 marks, you write the correct formula, 1 mark already. Balancing the second mark. If your formula is wrong, you will never balance correctly, immediately 0. So make sure your sequence is correct. Then some students will ask me, what's the difference between like 2H and H2? When you write 2H, you are saying 2 hydrogen atoms, not chemically bonded together. When you write H2, that means got chemical bond, they are together. Got difference. Okay, like this one here. Okay, so this example is to go through your diatomic. Next example, we introduce ionic compounds. Need to recognize. These 2 got metal, non-metal inside. To get a chemical formula, we write the ions out. Potassium is group 1. Periodic table group 1 is plus. Group 17, minus. Okay. Then just balance the charge to get formula. Chlorine is group 17, halogen, so Cl2. Okay. Balance the charge, Ki. So make sure you leave some space. Remember your balancing is the last step. Okay, then now you go and balance. Okay, last one. Introducing metals. So generally there's 3 different types of substances. Ionic, covalent, metals. When you see metals, it's just the chemical symbol, no plus here. The plus only is when it's an ionic compound. So for those that learn periodic table chapter, this should be more familiar to you. Sodium hydroxide, ionic. So just write out Na plus, OH minus. Okay, I think most of you also learn acid alkali already, right? Sodium hydroxide, see a lot of times, write a lot of times. Okay, formula all done. Then you realize that sodium and oxygen balance already. So don't be afraid to change things, because you realize that here got 2 hydrogen, here got 3 hydrogen. Left side not enough, right? So if you're really scared, use pencil first and see whether it works. Because you keep staring at anything, you do mental sums, it's very difficult. So try and error. So maybe I put a 2 here. If I put a 2 here, I am going to have 4 hydrogen. Can I get 4 hydrogen on the right? Put here. And then I put here. Okay, everything's happy, done. So don't just stare at the thing, use pencil, write down first, see if it works. So you can move forward. Oops. Yep, so metal no charge. I won't be going through ionic equations today, reason being that end of year at most 2 marks only, not worth my time. I need to spend 10-15 minutes to go through this. And some of you may not even be tested on this, so I'll skip this for now. Okay. Okay, I finished off the last chapter for Chem. Acid and bases, the good news, I only have 1 page for you here, okay? Very simple. It's just a summary. Acids produce hydrogen or H plus ions. Alkalis produce hydroxide or OH minus ions. Very common exam question. What's the name the ion produced? Right, when acid dissolves in water. Just write hydrogen, you get 1 mark. Yes, it's that simple. If they ask you to write the formula, then you write H plus. They ask you to write name, you spell out hydrogen. And this will be the main concept for this chapter. Everything you learn in this chapter is because of this. Your litmus paper change color also because of this. Okay? pH also because of this. Acids produce H plus ions. Your pH lesser than 7. pH lesser than 7 means I got more H plus than OH minus. That's what it actually means. Your pH equals to 7, neutral. It means H plus same as OH minus, same amount. That's why neutral. Alkalis, OH minus more than H plus. Just a quick check, did your teachers go through this or not? Explain pH, like that. Mostly, yes? Okay. Because this is actually newly added to your syllabus, like the concept is there, but now they are literally going to test that question. So if you look at the syllabus thing, what's happening? This one is the old syllabus. Old syllabus, you just need to describe acid, alkali in terms of the ions they produce and their universal indicator color. This old syllabus, right? But in your new syllabus, you got this additional thing: relative H plus and OH minus concentration. So they will ask you to explain what does pH lesser than 7 mean. They will ask you to explain why is this solution acidic in terms of this. For example, where is it? Here. Explain what is meant by acidic solution in terms of the relative concentration. This one you all don't have, this one on SEAB website. So that's how they're going to test this. You just tell me concentration of H plus more or higher than concentration of OH minus. 1 mark. Okay. So just know what the pH value mean and acidic and alkaline solution in terms of the concentration of the ions involved. Acids, there's 3 common acids to roughly know: hydrochloric, sulfuric, nitric. Alkalis got about 3 or 4. Okay, this one, most of your schools will use ammonia. Let's just follow along. In fact, the more correct one is ammonia. Okay, there's one more to add over here. I know not enough space. Calcium hydroxide. Calcium hydroxide is Ca bracket OH2 because Ca is 2 plus. Ca2 plus, OH minus, OH minus. Then how to remember this for? If it helps, SpCa, right? There are 4 alkalis. I'll only be teaching one ionic equation because this one is very commonly tested. Any acid, any alkali react together will give you this ionic equation. Okay, any acid, any alkali, doesn't matter what acid you use. H plus comes from acid, OH minus comes from alkali. Hopefully you can see the importance of the first sentence. You understand that you can form your ionic equation very easily without cancelling spectator ions, which is what your school normally teach you. Acid alkali cancel each other out to form neutral water. That's why called neutralization. If they ask you to name the reaction, then neutralization. Okay, then we have this term called bases, which include metal oxides, metal hydroxides. A base that is soluble in water, we call it alkali. So to help you understand this, base is very general, like living things. Animals, for example, is a specific kind of living things. So alkalis is more specific. Alkalis basically is soluble bases, got special characteristic. If bases is like animals, bases like living things. Alkalis like animal, it's a specific type. So it's actually a metal oxide or metal hydroxide that is soluble in water, we call it alkali. Then common exam question, what can you add to the soil? If it's too acidic, you just add calcium hydroxide. Just now you all written the formula already. Usually they will ask you to name, but if they ask you for formula, then just write this. Because it reacts with the acid in the soil. Calcium hydroxide is alkali, right? If you add more alkali, the pH is going to go up. Okay, we'll break after I go through this page. Okay, then your general equations for acids. Yes, unfortunately need to memorize this for. You realize they ask you write equation. Sometimes they just tell you the starting materials, they don't tell you the products because you are expected to know. This is where you are supposed to memorize all this. It is for. Okay. So hopefully this can help you memorize better. If you have carbonate, you can expect carbon dioxide to be produced. Ammonium, then ammonia gas come out. 3 and 4 actually very similar. So there's 3 acid reactions, 1 alkali reaction. Then the last part of acid chapter is your types of oxide. There is 4. But before we look at the 4, classify metal or non-metal first. Metal oxides is either amphoteric or basic. Amphoteric means can react with both acid and alkali. Okay. And what you're supposed to memorize over here, unfortunately again, is these 3. Is that zinc, aluminum, lead. If you really hate formula a lot, you prefer English name, sure. You can use LAZ. Okay, up to you. Zinc. Okay, then your non-metal oxides either neutral or acidic. Neutral oxides don't react with acid or alkalis at all. This one need to remember. So essentially for this section, only got 6. Your Z and your no cold water. Okay, no cold water. So how do you make use of this like flowchart? For example, they give you something like this. Okay, a bit scary, Okay, maybe okay, y'all don't write this first, Exam give you something like this. Exam give you something like this. Ask you what type of oxide is this. Okay, the first thing to ask yourself, is it metal or non-metal? Phosphorus is a non-metal. So is it neutral or acidic? Phosphorus cannot be found here, so it must be here. So that's how you're supposed to use this table. All you need to memorize is actually these 6. If it's not under emphatic or neutral, just throw to the other side. Because most of your school will probably give you some examples, like ask you memorize, but actually don't need. Your basic oxides, acidic oxides, are just dumping ground. Not emphatic, not neutral, just throw to the other side. That's it. Okay, so for example, your P2O5 will be here. Acidic. Then another example. Magnesium oxide. Magnesium is a metal. Metal, so we look on the left side. I don't see magnesium here, so it must be here. Yeah, that's how you use the table. So that's the correct thought process. Okay. Then one last example. Nitrogen dioxide. Okay. Non-metal. So look on the right side. Neutral or acidic? Common exam trick lah. This is nitrogen monoxide. Mono means one. NO and NO2 is different. Okay, they are not the same thing. Teachers also know students will remember like these 3. So that's why they like to test like carbon dioxide and nitrogen dioxide. NO2 is actually here. Because it's not here, throw to the other side. CO2 also here, throw to the other side. Okay. Sorry, last one. Teachers also like to give this thing called potassium oxide. Potassium starts with letter P, right? But the formula actually is K2O lah. Why do teachers like that? Because teachers also know students remember Z. Got P ma? A lot of students will think potassium is amphoteric, but it's not. Your P over here is lead. Okay, this is lead. So potassium oxide is here also. If you find this very difficult, minimally amphoteric. This is the most commonly tested one. Okay, at least like amphoteric, what does it react with? What are your 3 amphoteric oxides? This is the minimum. Okay? Yeah, if not, we break here. Online people, yes, just put your question in the chats. Okay, we break 5 minutes, 11:08. Yeah, then snacks can help yourselves, or those of you that are here. Okay. Yeah, 11:08 we resume. If you need to take a walk, please help yourself also. By the way, there's toilet there, by the way. Physical people have questions? No? let's continue. We have about 20 more minutes to finish up Chem. Then we go to physics. Let's try the questions. I will start from question 13, which is on page 41. Page 41. I want to take more. I thought I want to take. Okay, page 41. This question got error. Okay, this is supposed to be neutralization, but neutralization is between acid plus base, not acid plus metal. This is metal. Write a balanced chemical equation. As I mentioned, metals, no charge, just the symbol. Hydrochloric acid, you should have written a lot of times. Let the muscle memory do its work. So you notice they give you the reactants only, they never give you the products, means you are expected to know and memorize. Metal plus acid give you salt plus hydrogen. Salt will always change depending on what you have. Write hydrogen first. Hydrogen is fixed one. What is the salt? There is two ways to get. First way, look at what thing haven't come out yet. You need to balance the equation, right? It has to come out. Then you write the ions. Salts are ionic compounds. Ionic compounds use the ions method. Balance the charge, MgCl2. Okay, formula correct, balance. So first method, you go and see what is missing, haven't come out yet. Second method is you look at the name. Magnesium and hydrochloric acid will give you magnesium chloride. The salt name is magnesium chloride, then you write the ions out, get a formula. Also can, for those of you that prefer looking at name. So if you use hydrochloric acid, you will always get something chloride. You use nitric acid, you get something nitrate. You use sulfuric acid, you get something sulfate. That's how it works. Then this one we went through just now already. What can you add to the soil? Name. How does it affect the pH of the soil? It will react with the acid and cause the pH of the soil to increase. I think quite okay for 2 marks, right? Then we go to 11, last open-ended. The table shows the atomic structure of particles A to E. The letters of these particles are not the symbols. Key thing to take note over here, nucleon number is mass, not number of neutrons. Don't confuse, different. Nucleon number is mass. Okay, which is add your protons plus neutrons. The mass of an atom, or the mass number, is number of protons plus number of neutrons. Using the information, explain why particle B and C are isotopes. You get number of neutrons first. Mass number minus proton number, 8 and 10. And take note of instruction, you are required to quote values in this case. So cannot tell me same number of protons. I know many of you memorize definition, but that's not enough here. You need to tell me specifically F 8 protons. Okay, oops. Okay, in this case must specify, but okay. Wait, sorry. Let me try to phrase this. 8 neutron. Different. So isotope, same number of protons, different number of neutrons. This is 8, this is 10. Explain why they have the same chemical properties. This one always one standard answer only. Explain why elements are in the same group. Explain why similar chemical properties. To explain why something is the same, you need to go and find similarity lah. What is the same about these two things? Okay, specifically, same number of valence electrons. Outer shell electrons also can. Okay, done. A chemical reaction occurs because the outer shell electrons is being gained, lost, or shared. Okay, that's the whole basis of chemical reactions. Electrons are moving around. So it is the outer shell electrons that determine the reaction and reactivity. State electronic configuration of particle D. How will you arrange the electrons? 2.8. Why is it unreactive? It has a completely filled valence shell. Its valence shell is completely filled. Also can. Stable electronic configuration of a noble gas. Also can. And the last one here, which of these particles is negatively charged? Okay, for those of you that managed to get particle A, good job. I have 7 positive charge, 10 negative charge. Okay. It has 7 positively charged protons and 10 negatively charged protons. Okay, must you write this? Some students will ask, so long-winded. Depends on your school again. Some schools will accept 7 protons, 10 electrons. Don't need to write this part. But if it's 2 marks, must confirm right. Okay, but these 2 marks, the mark allocation a bit different. This is 1 mark, this is 1 mark. Okay, then we look at the MCQ. Okay, I don't think I have time to go through everything. I also don't want to rush through. I will go through what is commonly tested, what you expect. what you are likely going to see in your end of year. Question 1 is the first one. This is called displacement of water. It's used to collect insoluble gases or slightly soluble gases. Because if the gas is insoluble, it cannot stay in the water, it must come out. That's how you collect the gas over here. That's how it works. Why is it called displacement? Because when the gas comes out, it's like pushing out the water. Gas is metal, it occupies space, it will push out the water. That's why it's called displacement. Then most of you are physics students, so this shouldn't be an issue. For something to rise or float, it should be less dense. It is called upward delivery. If the gas is less dense than air, then it will rise or float. If it's denser, then we use the downward delivery, which is just the other one. Okay. Because denser objects will sink, less dense objects will rise. I will be skipping 2, but those that tried it, here, B. If you want, you can ask me after class as well. Okay. 3. Kinetic particle theory. In which substance will the particles vibrate about fixed position? Solid. In other words, the question is asking you what will be a solid at 22 degrees Celsius. So imagine a math number line. Okay, melting point, boiling point is like your 2 markings. Imagine a math number line. Where will you find 22 on the first number line? 22 should be here, greater than minus 50. 22 should be here, between minus 1 and 25. Imagine a math number line. Where is 22? Here. Between 0 to 100, here. Anything on the left side, solid. Anything in the center, liquid. Anything on the right, gas. Answer D. This is called the number line method. This applies to physics as well, okay? Then Al3 plus. If you look inside your periodic table, you will see this. The smaller number is your proton number. Yes. What does 3 plus mean? 3 plus means lose 3 electrons, lose 3 negative charge. Let me write properly. After you lose 3 electrons, you will have 10. Neutrons is just mass minus proton 14. Okay, answer A. Okay, I'll be skipping 5 as well. 5 answer will be B. To explain simply, okay, maybe I go through this. Like this question may not come out, but you need to understand like how all this electronic configuration works. This is your number of shells, 2 shell, 3 shell. Okay. 2 electron shell, 3 electron shell. 3 electron shell means it can be found in period 3. 2 electron shell means it can be found in period 2. So if you actually go and trace back, 2,5 is nitrogen, which is found in period 2. 285, phosphorus. Okay, if you want, you can go and trace lah. Okay, therefore answer is B. Got more electron shell. This one got additional 3 electron shell. And they are in the same group. How do I know? Same outer shell electrons. Group 15. Okay, so maybe I just write here. Period number, number of electron shell. Group number, the ones place, just now I mentioned. Number of outer shell electron. last three. What's the answer for 4? Oh yes, A, sorry. C only. Okay, go to 8. Ew, what's this? Common misconception, this one is an element, not compound. One type of atom only. So we label as E1. Only got white ball, right? So one type of atom only. Compound, 2 or more type of atom. Chemically bonded together. They must stick together. So this is compound. This is an element. This is the second element. Got 2 different elements inside. Mixture of elements. So that's how you all should approach this kind of question. Compound 1, got black ball, white ball stick together. 2 different type of atoms. Element 1, element 2. So mixture of elements and compounds. Answer is 1, 2, 3, 4. Okay, then 9. Universal indicator turns blue. In your whole syllabus, there's only one thing that can do this lah. Okay, ammonia. Why? Because alkali ma. Alkali will cause it to turn blue. In other words, the question asking you what will react to give you alkali. So, what will react to give you ammonia gas? Alkali plus ammonium salt. Give you salt, water, ammonia gas. Then last one, types of oxide. So usually the easier one is your neutral and amphoteric. So start from there, then eliminate from there. Sept, zinc, aluminium, lead. 50% already. This is a non-metal. Non-metal is either neutral or acidic. Okay, your neutral is no cold water. Just now I mentioned, right, carbon dioxide is actually acidic. So first question, is it metal or non-metal first? Then 50% already. Okay, any questions for Chem? Maybe we take a quick break, 2 minutes, then we go to physics. Online people, questions? Physics is page 21. For physics, we will cover kinematics, dynamics, and moments. There are a lot of tests on that. So your school started with waves. Your school tests anywhere. Up to kinematics. So your school started from waves, is it? Or thermophysics? Heat. Waves. No worries, the topics later quite. It's difficult, but today the questions very. Right, kinematics formula same as your E-math. Okay. The thing that I want to highlight for this part is speed is a scalar, only got magnitude. Velocity is a vector, got direction and magnitude. Okay, so speed and velocity kind of the same thing, it's just that velocity need to account for direction. So for example, if I'm moving to the right, then my velocity is 20 meters per second. If I'm moving in the opposite direction, then my velocity is minus 20 meters per second. The minus sign is there to indicate the direction. That's the difference for velocity. Sorry, this should be here. Okay. The minus sign is there to indicate the direction. Minus means opposite direction. Next thing to highlight is acceleration. Acceleration will change when speed or direction change. Yeah, acceleration will change when speed or direction change. So to help you understand what acceleration essentially is, there's two main kinds. The first one is uniform, means consistent acceleration. Hopefully you can see that the velocity or the speed is increasing by 5 meters per second every second. That's what acceleration means. How is your speed changing per second? By 5 meters per second every second, we write as 5 meters per second squared. The other one, decreasing, right, by 10. Acceleration is minus 10 meters per second squared. So the object is slowing down or decelerating. If question asks for deceleration, don't write negative again. D already means negative. So acceleration minus 10 meters per second squared, deceleration is just a number without the sign. Okay, if you write negative, then minus 1. Then you have non-uniform acceleration as well. The speed or velocity doesn't change by the same amount every time. It's random. Okay, hopefully you can see. That's non-uniform acceleration. Okay. Then you have the concept of free fall. Sometimes you will see in your exam questions, ignore air resistance, assuming air resistance is negligible, all those kind of things. It means they are testing concept of free fall. So try to recognize it when they test it. When you are being tested on free fall, okay, objects will accelerate uniformly. Constant acceleration of 10 meters per second squared. Okay, to the center of the earth. Just now we learned about acceleration, right? What does it mean? It means the speed of the object will increase by 10 meters per second every second. So the object will fall faster and faster. Concept of free fall is very difficult to imagine because we don't see this in reality. So under free fall conditions, right, when you drop a feather and bowling ball, they will hit the ground at the same time. But the issue why we don't see this in reality is because there is air resistance. There's air around us, right? If you want to see this, then you need to go outer space to see. Because outer space no air, but here got air. Okay, so as long as you understand or identify concept of free fall being tested, it's always the same thing. This is the main thing. 10 meters per second squared. Constant acceleration. So since both the bowling ball and feather speed up by the same amount every second, they will hit the ground at the same time. That's for free fall. Okay. Then you have a distance time graph. First thing to recognize is that the gradient of the distance time graph represents your speed. What is gradient again? Gradient is your steepness. Constant gradient, constant steepness. What does gradient represent? Speed, right? So constant speed. Identify what the gradient represents first. Then change the word gradient to what it represents to describe motion. Exam questions will ask you to describe the motion of the objects, right? Identify gradient first. Change the word gradient to what it represents. But you must see how the steepness is changing. Okay. Constant steepness, so constant gradient. Gradient is 0 over here. In other words, the distance is not changing. Why? Because not moving. Stationary. Then for this part, should we draw here? Okay, don't draw here. I draw outside. Hopefully you can see it's getting steeper. Increasing steepness, increasing gradient, increasing speed. Okay. Hopefully this makes it easier. The other one, the gradient or the steepness is decreasing, getting gentler, so decreasing speed. So this is one way to look at it. Okay, some of you may require this method instead. Okay. So let's say we look at this part every second. What's happening? From 6 to 7, the distance increase like that. 7 to 8, your distance increase like that. 8 to 9, your distance increase like that. 9 to 10, your distance increase like that. Can you see that you are covering more distance each second? Why? Because you are traveling faster. Okay, you can do the same for the other side also. This is just another way to look at it. Why are you covering more distance? Right? In the same period of time? Because you are moving faster. Okay. Speed time graph. Gradient represents acceleration. Area under graph represents your distance. Got two things to take note here. The first part of the graph is the same, right? Just now you all saw this part already. Same thing, just change the word gradient to what it represents. Constant steepness, constant gradient, so constant acceleration. Uniform acceleration also accepted. Okay. Yep, I'm not going to repeat this 7 times, but the key thing that I want to highlight for this is if the gradient is positive, upward slope, it means the object is accelerating, speeding up. The speed is increasing what? Right? So it means the object is speeding up. When you have negative gradient or downward slope, your speed is decreasing. It means your object is decelerating, slowing down. So just change the word accordingly. If it's negative slope, change to deceleration. Okay. Then just be careful of this part as well. Okay, maybe I show for this part here. Over here, you are getting less steep. Getting flatter, ma? Okay, but when you go to the other side, you are getting steeper. What happened? Okay. Okay, so this is the reason why from 8 to 10, increasing deceleration, your steepness or gradient is increasing. Okay, your steepness or gradient is increasing at this point. So just be careful. See how the steepness is changing. Then I highly recommend you all to memorize this formula as well. It will be very useful. Area of trapezium. Later you will know why. Okay. I go through. Let's go through this. Page 48. Calculate the deceleration, page 48. The slowing down part. So just apply formula. Final speed minus initial speed divided by time. Final speed is 0. Starting speed is 40. Time is from 40 to 60, so 20. Okay, equals to, if your school has a 2SF rule, then you just follow and give them. And write the 2.0. Wait. This is deceleration, so don't write negative sign again. Okay, deceleration, don't write negative sign again. And be careful of your presentation. If they ask you to calculate deceleration, we still use acceleration formula. Okay, and if you write this, you will get -1. Because the formula is incorrect actually. If you write this up. Some of you may prefer to use the gradient formula y2 minus y1 over x2 minus x1. That is actually fine. Okay, so I can show you. This one is 60, 0. This is 40, 40. If you use your EMATH gradient formula, let me see, this one is. Let's say you use your EMATH gradient formula. 40 minus 0. Then it should be 40 minus 60. You will still end up with a negative answer. So regardless what formula you use, you should end up with the same answer. Because a lot of students know deceleration should be positive, they write like that, then they -1. This formula is incorrect. Because your acceleration should be negative, what? It's a downward slope, what? Your final answer calculated should be negative at first. But since question asking for deceleration, then you remove the minus sign. Okay. If you calculate this out, you get +2, which doesn't make sense. It's a downward slope. Okay. Calculate the total distance traveled by the car. So it's the area under your graph. So if you don't memorize your trapezium formula, then sorry, you need to calculate 3 shapes. 2 triangle and 1 rectangle. I mean, yes, you still get the marks lah, but a lot of effort lah. If you memorize the formula, half times A plus B, what is your A? Here to here is 30. The length of parallel sides, 30 plus 60. Then your trapezium height is 40. So times 40, 1800. Okay, calculate average speed, total distance divided by total time. Total time is 60, 30. Okay, then something to take note for this graph is, let's say if they ask you to describe motion, common exam trick as well. For this part, the car is still moving, okay? It's not stationary, there is speed, it's still moving. So watch out for the axis. This is a speed time graph, not distance time graph. The car is moving at constant speed of 40 meters per second. Okay, we look at dynamics. Dynamics is your 3 Newton's law. In Newton's first law involves balance forces, means your resultant force equals 0. Most of the students will understand the left one. If resultant force is 0, then the object will not move, remain stationary. Okay, but it's the right side one. If the object is already moving, and resultant force is 0, the object will continue to move, it will not stop. Although the resultant force is 0, but if the object is already moving, it will continue to move at constant speed. So there's 2 different scenarios. If the object is not moving at first, then it remains at rest. If the object is already moving, it will continue to move at constant speed. Okay. Then your Newton's second law, unbalanced forces, means your resultant force, you can just write this, FR. Not equals to 0. Okay, your first law and second law basically both involve this formula. Your first law states that resultant force is 0. Okay, mass cannot be 0, right? So means what? Your acceleration is 0. Your object will not change direction, your object will not change speed also. That's the Newton's first law. Okay, but if you have resultant force, then now you're going to have acceleration. A resultant force can cause objects to change direction, speed up, slow down, do a lot of things. What if your forward force is greater than your resistive force? In this first example, then the car will speed up in the forward direction. Quite logical, right? So there's a few things to take note over here. If you are moving, if your resultant force is in the same direction as where you are moving, then you will speed up. Let's say if we are moving from left to right, your resultant force is going against you, then you will slow down. Okay, if you are trying to move to the right, resultant force going against you, you will slow down. Okay, then the last page for dynamics. Newton's third law, just take note, this is newly added to your syllabus as well. Okay, Newton's third law is just an action-reaction pair. To put it simply, for every action there will be an equal and opposite reaction. So if I ask you to bang your head on the wall, why won't you do it? Because you say feel pain. But why do you feel pain? How do you explain that using physics? You hit the wall actually hit you back. That's what Newton's third law is. You hit the wall hit you back with the same amount of force. That's why you punch the wall harder, you feel more pain lah. You just touch the wall, you don't feel pain. Okay. Then there's two things to take note over here. For Newton's third law, there's two criteria. Equal, opposite, and same type of force. Second criteria, force on two different objects. Two different objects. So I'm going to show you an example of how teachers will trick the students usually. Usually it's the left side scenario. Okay, I'll go back to that later. So then I'll copy it. Let's say your normal force is 500. Your weight is also 500. Equal and opposite one. A lot of students will think this is Newton's third law, but it's not. Why? The second criteria is not fulfilled. The forces must be on two different objects. Just now the box or the object, only one. Right? The two forces are only on one object. It should be on two different objects. Okay. So just take note of that. And the last part. Friction, two things to take note. A lot of teachers will just tell you friction always act in the opposite direction. For walking and car wheels, okay, these two are special examples. Because your car wheel is rotating like this, the friction will act like this. Same direction as where you are going. Same thing as you are walking. For you to walk forward, your feet is actually exerting a backward force. And then the friction, okay, is acting in the opposite direction. This is your friction. Friction is the one that actually pushes you forward and allows you to walk. Very simple analogy. You go ice skating, no friction. Can you walk or not? Cannot. Friction is the thing that allows you to walk forward. Okay? Okay, now we go to the question, then we break. This one is 49. Okay, there are two forces acting on the car. The car has a mass of 1,300 kg. Explain in terms of forces. Question already stated what they want. Why the car move at constant speed? Got force what? There is a force. Why the car move at constant speed? Anyone know? Why constant speed? Y'all can just whisper, I can read your lips. Why constant speed? But that's not the keyword that they want. Why no acceleration? Constant speed means no acceleration lah. Why lah? You are just rephrasing actually. I haven't answered the question yet. Yeah, resultant force 0. Not resistive force 0, resultant force 0. Just now I stated, right, your Newton's first law. If the object is at rest, resultant force 0 remain at rest. If the object already moving, resultant force 0, constant speed. So whenever you see constant speed and you recognize that you are being tested on dynamics, just do this. If you can write resultant force is 0 in your answer, 1 mark already. Okay, but that's the second point, so write in the second line. The first mark comes from why is the resultant force 0? What can you tell me about the two forces? Equal and opposite direction. The driving force is equal and opposite to the resistive forces. That's why resultant force 0. So for those that need numbers, example, maybe this is 5,000, example, then this 5,000, example. Equal and opposite, cancel each other out. At one point of the journey, the car has a uniform acceleration. Different scenario already, the car is accelerating now. Why is the car speeding up? Because got resultant force lah. Then you go and calculate. Mass 1300, acceleration 2.5, 3250. Newton. So in your whole physics syllabus, there's actually only 2 formulas involving acceleration. Usually they like to test together as well, under one question. But over here I separate it lah. So do take note, sometimes you can test both formulas in one question. Maybe you calculate the acceleration using this formula first, then you throw inside to calculate what you need. I calculate only. Yeah. Oh, okay. If the car experiences a resistive force of 1,250 newtons, calculate the driving force of the car. So sometimes you can draw your own diagram if you need help visualizing. Resistive 1250. What is this? So that the resultant force overall is 3250 minus. Okay, so there's 2 methods. For those that prefer to memorize formula, resultant force equal forward minus backward. For those that prefer formula. Okay, 3250. Forward is, you don't know, minus 1250. So forward equals to 4500. So this is the formula method. There's also the guess and check method. Should you plus? Should you minus? Try both out, see which one makes sense. So let's say if you minus, you will get 2000. Then right here, lor. Right side 2000, left side 1250. Can get this resultant force or not? Cannot. That means you plus. Try the other one now. Okay, so over here 4500. Okay, now this will give you 3250. So this is the guess and check method. See whether your answer makes sense or not. I'm not sure how many of you actually have time to check your answer in the exam. Okay. Six, seven. Okay, enough. We break. Slightly longer, 7 minutes. Got questions? Can ask now also. Yeah. Got questions? Can ask me now. 12:07. Question? Question? Okay. What is happening? Okay, energy. This one, for those that didn't try, maybe I'll give you some time to try. Then for those that try, I will go around and see. Mainly the calculations lah, okay? This one should be page 50. Mainly try A. First one is just this. Your G is 10. Sometimes they don't give you, expected to know. M is mass, G is gravitational field strength, H is height, 150,000. Then calculate the maximum speed that the kite can reach when it reaches point B. If you are being tested on energy and they ask you for speed, I know it's very tempting to use speed distance time formula, but there is another formula which has speed in energy chapter. Okay, it's your Ke lah. K equals half mv squared. V is also speed. Okay, but before that, let's try to understand what's going on here. I have this amount of energy, and because the kite is at rest, which is not moving, right? So the kinetic energy will be 0 at first. Got some height, so got gravitational potential energy, but not moving, so 0 kinetic energy. Assuming that there's no energy loss, because they say maximum speed, right? No energy loss to surroundings. Means all the energy will transfer from this to this. Okay, as it reaches point B lah. Point B, the height is 0, right? So the EGP is 0. 0 height. Kinetic will be 150,000 now. Okay, So this is your principle of conservation of energy, which states that energy is not created or destroyed, but it can be transferred from one energy store to another energy store. So the first statement that you write for the first mark, decrease in GGP. Okay, you all can just use this lah. Equals increase. Then you form your formula. Ke equals half mv squared. What's the amount of kinetic energy at B? 150,000. Throw it in. Mass is 500. V is your speed. Okay, this is the part where you need your E mass. If you do everything correctly, you should end up with 24.5. It now means the E mass part affected. Okay, so what I suggest, let's say if you are not very strong in math, it's okay. You just do step by step. One additional step only. You simplify the right side first. Half times 500. 500 divided by 2, 250. You move one by one, just like making the subject like that. Okay, move one by one. Okay, then the last step, just square root both sides. You should get your answer. Okay, if you want, you can simplify this side also. This will be 600. Which is equal to 24.5. 3 SF or 2 SF if your school wants. So why is it not possible for the card to reach this speed in reality? Because air resistance is around, friction is around, there will be energy loss. For this one, you follow what your school say. You all follow which one more familiar. This one is like the old syllabus, they use this, but I'm not sure if schools still accept this. At this point, energy chapter still very messy. All schools teaching different things. So my reference point or what I teach is from the textbook. Then the other one is sum of the energy in the gravitational potential store is transphase. Means the surrounding lah. The energy store of the surrounding. Maybe you can add this in also, just in case, due to friction and air resistance. Okay, quick check. Any of your school teachers still use the word converted? Conversion. Converted, conversion. Okay. But your teacher will go through energy store. Okay. The converted conversion, is it? part that is wrong is the old teaching model in the old syllabus. Because the old teaching model states that energy got many different types, so can be converted to different forms. But in the new teaching model, only one type of energy. But this energy can move from different place to different place. I wouldn't totally rule out that it's wrong at this point. I know some schools don't accept converted conversion anymore. But from what I heard, Cambridge still accepts. Because I mentioned, right, all schools teaching different things now, I don't know who's correct. Yeah, so I'm trying to find out. Okay. Right, MCQ. Oh wait, sorry, before we go MCQ, got one more chapter. I finished that up first. Just 2 pages, I think. Yeah. This is page 28. Just now we learned that resultant force can cause things to slow down, speed up, change direction. A resultant force can also actually cause things to turn. Force can cause things to turn, right? That's what moment is, turning effect of a force. So you have a definition over here. Formula to calculate moments or turning effect is force times distance, but this distance must be perpendicular. Perpendicular. Moment is a vector. Got magnitude, got direction. In terms of rotation, can be clockwise, anti-clockwise. So let's say if this point is fixed, we call a pivot. If you have a downward force over here, hopefully you can imagine this thing will rotate clockwise. Okay, this downward force will cause this thing to rotate clockwise about this fixed point. If you have an upward force, then it will cause this thing to turn like that, which is anti-clockwise. So this is the first level of this chapter. Can you visualize clockwise or anti-clockwise first or not? And are you able to calculate moments? This is the first level. Okay? Once you are okay with this, then you look at the second level. Principle of moments. For an object to be in equilibrium, balance, does not turn, the total or sum of clockwise moments, total clockwise, must be equal to the sum of anti-clockwise. A bit like the resultant force like that, they cancel each other out. That's why the thing does not move or rotate in this case. Okay? Total clockwise equal total anti-clockwise. Hence, objects will remain stationary and don't rotate. So an example over here. A metal bar PQ has a weight of 8 newtons and is pivoted at P. Okay, so fixed point P. It is prevented from turning by a Newton meter acting at Q. If you have this force over here, how will the thing rotate? Clockwise or anti-clockwise? Can you all visualize? Clockwise or anti-clockwise? Clockwise. Okay, it will turn like that, so clockwise. Okay, so what you do is you do clockwise. Do I have yellow? Okay, I have. Okay, I'll just put here. They mentioned that this thing does not turn. So what does that mean? There must be something causing anti-clockwise moment to cancel this effect. So where is it? It will be here. And this is outward force. Because when you have upward force, okay, this thing will rotate like that. So that's your anti-clockwise moment. Okay, so what you do now is you form your equation. Total clockwise equal total anti-clockwise. My clockwise moment is force times perpendicular distance, 8 times 0.25, anti-clockwise. Okay, equals to your anti-clockwise, which is 0.25 plus 0.25 times the force, which is what you are trying to find. Remember, the perpendicular distance is always from the pivot, the fixed point. And then you're going to solve for F. Okay, your force will be 4 newtons. You can put anti-clockwise on the left, also up to you. Doesn't matter. Everyone okay for this? It's about moments. Then the last thing for this chapter is your center of gravity. It's a point where the whole weight of the object appears to act. This is the official definition, but to put it simply, where is majority of the mass? Okay, where's majority of the mass? For an object that has regular shape, uniform density, center of gravity will be at the geometrical center. This is where the weight will appear to act from. So this is the reason why when you draw your free body diagram, the weight usually will start from the center. Okay, so this is the center. Center of gravity can also lie outside of the object. In the case of a ring or donut, the center of gravity will be here. Because if you try to draw all this line of symmetry, the intersection point is at the center. Okay. Right, that's it for the teaching. Then we go and look at question . Let's clear the moments one first. 7 and 8. 2 questions for moments. What is the moment produced by a force F? Okay, I have this force about the pivot P. Okay, for those flipping, page 45. Pivot P is here. Let's see. Moment equals to force times perpendicular distance. Your force is like this. Where is the perpendicular distance? Here. Yeah. So just this. That's why the word perpendicular is very important. They are going to give you a lot of distance to confuse you. Find your force, find your pivot. Ask yourself, where is the perpendicular distance? Okay, maybe a more applicable example would be like your door. Let's say the door is halfway open already. Okay, then let's say I exert a force like that. Do you know where's the perpendicular distance? Okay, maybe I use a simple example, like straight line. This is the door, example, door. Then you try to push open the door using this amount of force. Can you identify the perpendicular distance from the pivot? This part of the door is fixed, right? So this will be the pivot. So your perpendicular distance is actually over here. Hopefully you can see. Okay. So moment, be very careful. Always look at your force, look at your pivot. Ask yourself, where is the perpendicular distance? A lot of students will use this, which is incorrect. Okay, you only use that if the force is like that. Then okay lah, perpendicular mah. Then you use this one. Okay. Right, then this. Principle of moments. Uniform means everywhere the same. This is a very important word. Where will the weight of the ruler be in this case? Because it's uniform, the weight or the center of gravity of the ruler will be at the center. 50 cm marking lah. So the weight is here. So they say in order to balance the bar, a weight of 10 Newton is glued over here. They say the bar is balanced, right? That's where you need to apply principle of moments. Why is this thing balanced? Why is this thing not rotating? So clockwise equal anti-clockwise. Which one will give you clockwise? Which one will give you anti-clockwise? That's why you need to know how to visualize the first level first. This one, this is your pivot, by the way, the triangle. If you have a force like that, the thing will rotate like this. So we call this anti-clockwise. So we throw inside. This is the 50 cm mark of the ruler. That means this is 20 cm. 1 meter ruler, right? Halfway is 50 cm. So here to here is 20 cm. So 20 times W. Then your clockwise is over here. You have a downward force. 30 times 10. You just throw everything in, then you slowly go and solve. Then you will get 15. Weight is a force, so the units is also okay. For those that need more time to process, you can try to process this. Those that are done, okay already, y'all can try the question 1 for the physics MCQ. Questions can ask me also. Okay with this? Y'all have questions? Which one will increase the period of a pendulum? Period is time taken for one swing. Let's be a bit more professional. One oscillation. Okay. Key concept over here is that only the length will affect the period. So if you need to visualize, you can draw something like that. One longer, one shorter. It needs to travel a further distance for one swing. So take longer lah. This one travel shorter distance mah. So shorter period. So how to remember easily? Longer pendulum, longer length, so longer period lah. Same. Shorter length, shorter pendulum, shorter period. Shorter time for one swing. C and D, they are usually just distractions. The mass and the angle don't really affect. Main concept is the length. For scalar and vectors, these are a few examples that you all need to know. Scalar only got magnitude, no direction. Your vector got this and this. I'll just add on a few more examples to this list. Okay, maybe I add over here so don't confuse. Scalar, temperature, mass, anything else. Time, distance is there. Okay, speed is also a scalar. Then vector, I have acceleration. Acceleration is a vector. Weight is also a vector. These are the common ones. Then 3. The object was brought from Earth to the Moon. How will its mass, weight and density change? What's different about Earth and Moon is the gravitational field strength. Your Moon has lower gravitational field strength, lesser gravity. Remember, mass is not affected by gravitational field strength. Mass is the amount of substance. Your number of particles on Earth when you bring to Moon is still the same, so the mass will remain the same. Okay, weight, W equals mg. Weight depends on two things, the mass of the object and the gravitational field strength. Weight simply means the amount of gravitational force acting on that object, if I have to put it simply. When you go to the Moon, there's lesser gravity, so the weight will be lesser. The amount of gravitational force acting on the object is lesser. Density, mass over volume. Your mass didn't change, your volume didn't change, so remain the same. Volume is the amount of space that it takes up. So answer is C. Then question 4. The diagram below shows an iron bar with a density of 8 grams per cm cube. I melt this iron bar and make into 4 equal cubes. What is the density of each iron cube? Answer is still 8, so common exam trick question. A lot of students will divide by 4, but no. Your mass divide by 4, your volume also divide by 4. Smaller cube one. So I show you, maybe let's say, for example, maybe I use 60. Okay, let's use this. Density, okay, like that. So this is the mass. This is the volume. When I cut this thing into 4 smaller pieces, the mass divide by 4. The volume also divide by 4. Can you see the density remains the same? The density is still 8, ma? Okay, 5. A brick of mass 5 kg stands upright on the ground as shown. The gravitational field strength is blah blah blah. What is the smallest possible pressure? You want small pressure, you need large area. You spread out your force so that the pressure is lesser. So it means you'll be using this side. This is mass, this is not a force. You want to convert mass to force, you need to convert it to weight. Weight is a force, newtons. So apply this. Okay, then 50 newtons. Your G is 10 now. Okay, over here 5 times 10. Convert your mass to weight to get a force. You want a larger area, 10 times 16. You divide by a larger number. If your denominator is larger, then you'll get a smaller answer. That's another way to look at it. Okay. Yes, this one mentioned already, just be careful for whales. Friction is here. Air resistance, your air particles going against you. So if you are trying to move forward, air particles will collide against you. So air resistance in opposite direction. For those that cycle a lot, run a lot, you will feel air resistance. Right? The wind is actually air resistance. Okay, last two. A box weighing 50 Newton is pushed horizontally on a smooth surface by a 10 Newton force for 6 meters in 10 seconds. What is the average power used to push the box? We will be needing two formulas over here. Work done equals force times distance. Okay, but please be careful. Just now we learned moment equal to force times distance. Same formula. But there's a very important difference. For work done, this distance, right, must be same direction as force. Same direction as force. Just now for moments it was perpendicular. For work done it must be same direction as force. Your box moved 6 meters due to this 10 Newton force. Okay, work done in other words is the energy transferred. This is the amount of energy transferred to the box when you push it like this. Units is joules. Same units as energy. Okay, then now the second formula. Power equals to work done over time equals to energy over time. Whenever you are dealing with energy, work, power chapter, everything must be calculated in SI units. Your distance must be in meters, your time must be in seconds. Okay, in this case, seconds already, right? So just throw it in. 6 watts. How can you understand power? What is power all about? Basically, it's how much energy you use per second. That's what power is. Okay, how much energy you use per second to push the box. Then the last one. Work is done when a force of 400 Newton pulls a crate of weight 500 Newtons at a constant speed along a ramp. Okay, I see this distance, I see a force that is the same direction. So as the box moves up, right, or for the box to move up, you need to transfer certain amount of energy to it. How much? Done. Energy transferred to box. You use the work done formula. $400 times 5. $2,000. Okay, and then when a box moves up eventually, two things is going to happen. How much energy is transferred to the gravitational potential store? How much gravitational potential energy did it gain? You use the formula to calculate. But be very careful. This is actually weight already. This is your mg. So don't go and times 10 again. So mg is 500. Your height is 3. Okay. So this amount of energy is transferred to the gravitational potential store. In other words, it gained 1500 joules of gravitational potential energy. Using principle of conservation of energy, you know total energy should remain the same. How much energy is lost due to friction? Work done against friction. You just take 2000 minus 1500.